problem, we will solve the example number 4 of chapter 5, equilibrium of rigid bodies in 3D. First of all, what we like to know is that we have a uniform plate that has a weight of 500 pounds supported by 3 cables, and we want to find the tension in each of those cables. So to solve this problem, the step number 1 is to see if we have a coordinate system, and we do. This is x, y, and z, and then the second step will be do our free body diagram. So I will draw my free body diagram over here, free body diagram. To draw my free body diagram, I'm going to draw the axis, and then I'm going to draw my plate. And then I will draw the active forces. The active forces are the 200 pounds. And the weight will be located at the middle of the plate, so it will be located out here, 5 pounds. And then I will draw my reactive forces. My reactive forces will be TB, TC, and TA. Once I have drawn my free body diagram, I will take the equations of equilibrium. As you recall, equations of equilibrium are adding all forces equals to 0. That leads to 3 equations, 3 scalar equations, and then I have moment respect to a point. I could call it this, let's call this 0 as a vector, or I can also have moment respect to my axis, so that I have the 6 equations of equilibrium. So let's start with, as we see, this is my x-axis, this is my y-axis, and this is my z-axis. As we see here, when we add forces in x, we have 0 forces in x, and then we have forces in y, and we have 0 forces in y. So we have forces in z, because this is a particular case in where all the forces are parallel to each other. So forces in z, I will have TB plus TC plus TA minus 200 minus 500. So I could actually write already minus 700 equals to 0. As you see, this equation has 3 unknowns, so we need at least 2 more equations. And as we see, if we start with the moment about C, we see that all forces are parallel to C, so therefore we have 0 moment about the z-axis. Then we have moment about x. We have 2 forces that produce, or more than 2 forces. All the forces that have a distance between the axis and the force are perpendicular to the axis produce moment. So if we get this, we have here the distance will be 3 feet, right? And between the axis and the weight is 1.5 feet. So we can say that we have 3 times TC plus 3 times TA, right? And then we have negative 3 times 200, and then negative 1.5 times 500 equals to 0. Then we have to calculate the moment respect to axis y, and then we have the distance here is 4 feet, right? So we will have the moment will be 4, negative 4 times BC, negative 4 times DC, then half of the distance will be positive 2 times 500, positive 2 times 200. And T8 doesn't produce any moment because it crosses the axis. To solve the system, we will use the last two equations to solve for dA. So let me name the equation. This is equation number 1, equation number 2, 3, 4, 5, and 6. So I'm using equation number 5 to solve for dA, and that gives me that dA is equals 450 minus dC. Then I will use equation 6 to solve for dB, which is equals to 350 minus dC. Then with those two, we can use equation 3, and we find dC, which is equals to 100 pounds. And then we have, and then we can substitute in the other two equations, and then we have dA, which is 350, and dB, which is 250. And those are the results for this problem.